Hello. Now we start our second use of dimensional analysis. Second use is to establish the relation between related physical quantities. That means to establish, that means we know that the period of a simple pendulum is given by t equal to 2 pi under root L by G, where t is the period of simple pendulum. 2 pi is the constant term. L is the length of string or length of simple pendulum, capital L. Small l is the length of string. G is the acceleration due to gravity. म्हणजे एखादं भौतिक समीकरण त्याचा संबंध कसा प्रस्थापित झालाय की त्याच्यामध्ये काय काय आलंय तिथे पी म्हणजे त्याच्या साध्या दोलकाचा आवर्तन काळ आहे. त्या टाइम पिरियडची किंमत दोन गोष्टीवर डिपेंड आहे. कोणकोणत्या? एक एल म्हणजे लेंथ ऑफ सिंपल पेंडुलम आणि ऍक्सिलरेशन ड्यू टू ग्रॅव्हिटी, ह्या दोन क्वांटिटीवर त्याची किंमत डिपेंड आहे. त्यालाच आपण आज काय म्हणता येईल, त्याला लिहिता येईल टी इज डायरेक्टली प्रोपोर्शनल टू एल रेस टू पॉवर ए and g raised to power b, or we can write here t equal to take some constant k, l raised to power a, g raised to power b, where k is called as constant of proportionality. Constant of proportionality. Here first we put dimension of t left hand side. That means we know that dimension of t is given by t is a period. For period, here mass is not needed, so we get here mass raised to power 0, l raised to length is again power 0, and t having power plus 1 is equal to k. K is called as constant of proportion, it is a constant term, so we do not find out its dimension. Now substitute dimension of, here we write k as it is. Substitute dimension of L. L is the length of simple pendulum. So we write here L is to power 1 and bracket is to power A into G. G is called as acceleration due to gravity. G ला आपण म्हणतो गुरुत्वीय त्वरण. We know that acceleration means change in velocity upon time. For change in velocity, we have to write here L1 t minus 1 divided by capital T. When we shift t into numerator, it becomes negative. So we write here L1 t raised to power minus 2. That is the dimension of G. So G is equal to change in velocity divided by time. L1 t minus 1 divided by t raised to power 1. So that is equal to L1 t minus 1 multiplied by t minus 1. It is equal to L1 t raised to power minus 2. So that is the dimension of acceleration due to gravity, and it has to power b. Here A and B are called as powers to be determined. A and B are powers to be determined. या ठिकाणी A आणि B ह्या संख्येची घात आहेत, त्याच्या किमती आपल्याला इथं कॅल्क्युलेट करायच्या आणि आपल्याला दाखवायचं की डाव्या बाजूचे आपल्याला या ठिकाणी पिरियड ऑफ सिंपल पेंडुलम ह्याची किंमत ह्या लेंथ आणि जीच्या काय संबंध प्रस्थापित करतो त्याला आपण म्हणतो डायमेन्शनचा सेकंड यूज. मग या ठिकाणी आपल्याला लिहिता येईल इट इज इक्वल टू m0 l0 t raised to power 1. It is equal to k using formula for indices. What is formula for indices? A raised to power m bracket raised to power n, it is equal to a raised to power m into n. इंडायसेस मधला हा जो फॉर्म्युला या फॉर्म्युल्याचा यूज करून आपल्याला या ठिकाणचं हे ब्रॅकेट सॉल्व्ह करायचं. काय लिहिता येईल? एल रेस टू पॉवर 1 मल्टिप्लाय बाय ए, दॅट इज एल रेस टू पॉवर ए. सिमिलरली in second bracket, L raised to power 1 multiply by B. 1 into B is B. That means we have to write here A plus B. T raised to power minus 2 into B. That is equal to minus 2B. Now in left hand side, there is M raised to power 0. But on right hand side, there is nothing. There is no term of M. So we neglect this term here. Neglecting m raised to power 0. Now comparing powers of m, l, t, or we can delete m. Comparing powers of l and t on both sides, right here. Comparing powers of l comma t on both sides, we get here L raised to power 0, L raised to power a plus b, that means a plus b is equal to 0. Similarly, in left hand side, t raised to power plus 1, here t raised to power minus 2b, that means we write here minus 2b is equal to 1. Now, from this equation, we find out value of a and b. So we get minus 2b equal to 1, that means minus b equal to 1 by 2 or b equal to minus half. Substitute value of b in this equation, we get a minus half is equal to 0, or we get a equal to, take this term on right hand side, minus become plus, a equal to half, b equal to minus half. Now value of k is found from experimental, that means from experiment, value of k is equal to 2 pi. This is determined from the experimental data. Now substitute this value in equation, we get equation becomes t equal to k l raised to power a g raised to power b. So we get t is equal to k into l raised to power a, l raised to power a, that means l raised to power half, into g, g raised to power b, b means value of b equal to minus half, and value of k equal to 2 pi. So we get t equal to 2 pi l raised to power half, that means it is in a under root of l, divided by g raised to power minus half, that means 1 upon under root g. So we have to write here divided by g. So that is the formula we got, t equal to 2 pi under root l by g. So this is the second use of dimensional analysis. Or we can derive another equation. We know that kinetic energy is equal to half mv square. So we take another example. Kinetic energy is equal to half mv square. Now we can write here kinetic energy is equal to k m raised to power a v raised to power b. Here k is called as constant of proportionality. Then a and b are known as powers to be determined. First we know that dimension of kinetic energy. The dimension of kinetic energy is equal to work done. So what is dimension of work? So dimension of work is equal to We write here W equal to force into displacement, and dimension of force is equal to M1 L1 T minus 2, and for displacement we take L raised to power 1. Displacement is nothing but it is a distance. So we get dimension of work done, it is equal to force into displacement, and that is equal to M1. Here L raised to power 1 base is same. There is a multiplication between these two. A raised to power m multiplied by a raised to power n is equal to a raised to power m plus n. 1 plus 1, that is equal to 2 t raised to power minus 2. So that is a dimension of work done, and dimension of work done is equal to dimension of kinetic energy. So that is equal to kinetic energy. So substitute value of kinetic energy here, dimension of kinetic energy. So we get 1 m1 L2 t raised to power minus 2 is equal. K is a dimensionless constant, so it has no dimension. Right here K. Here mass raised to power A. For mass we take m raised to power A 1 bracket raised to power A into velocity. तर velocityचं डायमेन्शन काढायचं म्हणजे काय लिहिता येईल आपल्याला L1 T minus 1 bracket raised to power B. Now again using formula for indices, a raised to power m bracket raised to power n is equal to a raised to power m into n. So that is equal to k m raised to power a L raised to power b t raised to power minus b. Now compare powers of m comma L comma t on both sides. Here is m raised to power 1, here is m raised to power a. That means we get a equal to 1. L raised to power plus 2, L raised to power b, we get b raised to 2. Similarly, t raised to power minus 2, t raised to power minus b, or we can write minus b equal to minus 2. That means again minus minus getting cancelled on both sides, we get b equal to 2. Substitute this value in above equation. In which equation? We write here kinetic energy is equal to k into m raised to power a. A means m raised to power a, value of a equal to 1, m raised to power 1 into v raised to power b. So v raised to power b, b is equal to 2. Again, here value of k can be found out. K is found out from experiment, and value of k equal to half. या ठिकाणी सुद्धा के ची किंमत आपल्याला डायमेन्शनच्या सहाय्याने काढता आली नाही, ती प्रयोगाद्वारे काढतात आणि के ची किंमत असते 1/2 1 हाफ, म्हणून त्याला लिहिता येईल आपल्याला हाफ. नाउ सबस्टिट्यूट व्हॅल्यू हिअर, वी गेट अगेन फॉर्म्युला कायनेटिक एनर्जी इज इक्वल टू हाफ mv square. Kinetic energy is equal to half mv square. That means to derive the relation between different physical quantities, we also use the uses of dimensional analysis. That means the second use of dimensional analysis is to derive relation between different physical quantity. एखाद्या समीकरणामध्ये ज्या काही वेगवेगळ्या क्वांटिटी आहेत फिजिकल, त्यांच्यामध्ये काय संबंध आहे तो दाखवण्यासाठी आपल्याला ह्या डायमेन्शनचा उपयोग होतो. हा डायमेन्शनचा थर्ड उपयोग. अशाच प्रकारे तुम्हाला होमवर्क दिलं, तुम्हाला त्या ठिकाणी तिसरी किंमत काढता येईल. नाउ होमवर्क फॉर दॅट इज find out dimension of potential energy. We know that formula for potential energy is equal to mgh. Potential energy is equal to mgh. This formula also proved using second dimension analysis, that is to establish the relation between a related physical quantity or to derive between relation between these three different quantities. Here m is the mass, g is acceleration due to gravity, h is the height. Again this value can be proved using dimension analysis. अशाच प्रकारे जर एखाद्या भौतिक राशी असतील, त्या भौतिक राशीचं त्या ठिकाणी असणारा जो काही संबंध आहे, तो संबंध प्रस्थापित कसा झाला, सुरू कसा झाला, हे काढण्यासाठी सुद्धा मितीचा दुसरा उपयोग होतो. त्यानंतर आपण पाहणार आहोत मितीचा तिसरा उपयोग.